Hi, Assalamualaikum and very good morning. My name is AIMAN with JUMANI and my metric number is 191962. Okay, today I will present about the dimensional analysis and modeling. So, what is dimensional analysis? Dimensional analysis is to generate non-dimensional parameter that help in the design of experiment and in the reporting of experimental result. So, to obtain the ceiling laws so that the prototype performance can be predicted from model performance. The last is to predict the trend in the relationship between parameters. So, we use the dimensional analysis and modeling in the future career, which is engineering design. So, we build the model for to know the characteristic of the prototype in the term of drag coefficient, drag force and everything. So we go to the experiment, we go to the example, and we can get the all the information. So we can get the temperature, pressure, temperature, density, velocity, length, height and weight. So the next is we find the drag coefficient of the model by using the formula force dividing by half rho v square and area, and we get the 0.758. The next is we find the Reynolds number of the model and Reynolds number of the prototype to know the flow is turbulent or laminar. After that, we go through to find the drag force of the prototype. So by using the half rho v square area drag coefficient, the drag coefficient of the prototype we can get from the drag coefficient of the model. So we fill the information and lastly we get the answer, which is 3,400 Newton. So the next is I will proceed to the method of the repeating variable. It is used to generate the non-dimensional parameter. It is a step-by-step procedure or recipe for obtain non-dimensional parameter. The step 1 is list the parameter in the problem and count their total number n. Step 2 is list the primary dimension of each of the n parameter. The step 3 is set the reduction j as the number of the primary dimension, calculate k and the expected number of its, k equal to n minus j. The step 4 is choose j, repeating parameter. Step 5 is construct the k its and manipulate as necessary. The final step is write the final functional relationship and check the algebra. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Safwan bin ANUARI. My message number is 192074. Okay, today I would like to present about a topic about dimensional analysis. Firstly, I will introduce what is the dimensional analysis. Dimensional analysis is to generate non-dimensional parameters that help in the decision of experiment and in the reporting of experimental result. Second is to obtain the ceiling loss so that prototype performance can be predicted from model performance. And lastly, to predict trends in the relationship between parameters. Okay, dimensional analysis have a principle, which is the principle of similarity. They have three conditions, which is geometric similarity, kinematic similarity, and then dynamic similarity. Okay, now we proceed to the example of the dimensional analysis. Okay, this is a solution. Okay, for T equal to 35 degree, density is 1.184. Dynamic viscosity is 1.849 times 4 of -5. Velocity is 56.8 mm per second. Length is 0.9 meter. height equal to 0.257 meter, and width equal to 0.159 meter. Okay, firstly we find the coefficient of drag, which is equal to force of model divided by half rho density model times velocity of model times by area. So we substitute the value, so we got the answer is 0.758. And for the Reynolds number for model, the formula is rho v w divided by nu. We substitute the value, we got the 7.3 times of 4.5. For Reynolds number for prototype, it's the same formula as Reynolds number of model, which is we got the answer is 4.27 times of 4.6. So lastly, we have to calculate the drag force of prototype by using the formula half rho prototypes times by velocity prototype square times by area and times by coefficient drag for prototype. So we substitute the value, we got the answer equal to 3,410. Okay, I finished at the dimensional analysis example. So we proceed to the method of repeating variables. Method of repeating variables is used to generate the non-dimensional parameters. It is a step-by-step procedure or recipe for obtaining non-dimensional parameters. It has 6 steps. The first step is list the parameters in the problem and count their total number of n. Step 2, list the primary dimension of each of the n parameters. Step 3, set the reduction j as the number of primary dimensions. Calculate k, the expected number of 2's, which is k equal to n minus j. Step 4, choose j, repeating parameters. Step 5, construct the k 2's and manipulate as necessary. And finally, write the final functional relationship and check the algebra. That's all from me. Thank you.
बोले चूड़िया बोले कंगना हाय मैं हो गई तेरी साजना.
Hi Dr. Kila, I'm KIRUBAANAND WASOO and my entry number is 194896, and this is my part of explaining dimensional analysis and also the method of repeating variable. So from the given question of dimensional analysis, we can actually let's take out some of the information given as the temperature, rho, mu, velocity, drag, h and width. So from here, the question needed us to calculate the drag coefficient and also the drag force which is exerted by the truck. So firstly we have to compare the truck between our model truck and also the prototype. So we have to begin with the coefficient of drag coefficient of our model. So the formula of drag coefficient of the model is actually drag force of model over half of rho of the model velocity squared times with area. So when we plug in the information given, and we will be getting a 0.755. From there, we have to get to the Reynolds of the model number. So when we find out the Reynolds number, it is 7.13 exponent 10 to the power 5. But it's not the end of that. We have to compare the Reynolds number of the prototype. The prototype is 4.37 times 10 to the power 6. So as a conclusion, the Reynolds number of prototype is specified has to be 16 times from the model. So as we can see, the Reynolds number of the model prototype have concluded that it is exceeding 5.5 exponent 10 to the power 5 of it. So as we can continue, we can confirmly tell that the drag coefficient is given as 0.769 the value of it from the previous calculation. So when we re-alternate the formula of drag coefficient, we can determine the drag force of it. The drag force is given as half rho v squared times with the area of the prototype and also the drag coefficient of the prototype. When you plug in back inside the values, and what's 1.184 and 26.8 squared the velocity, and this part of it, the 16 times values are actually 16 is due to the 16 times of the length bigger than the model, and also another 16 comes with bigger than the width. Then we can multiply the drag coefficient and we get the drag force, which is 8,400 Newton. And now I'm here to explain the method of repeating variables. The method of repeating variables is very easy to understand if we just follow the 6 steps given over here. Step 1 is to list the parameters in the problem and count their total number of n. Step 2, list the primary dimensions of each of the n parameters. Step 3 is given as set the reduction number of primary dimensions. Calculate the value of k, the expected number of pi's using k equals to n minus j. Then we can go on to step 4, choosing j as the repeating parameters. Step 5 is given to construct the pi's and manipulate as necessary needed. Step 6, write the final functional relationship and check your algebra.
Let it go.